back. That's essentially where I left off. And I said, well, step one, you should be drawing the triangle. Doesn't matter how well you have it visually, draw it visually on paper so that you don't forget, you don't mix up numbers, none of that stuff. So it's really important that you do so. Okay. So here we have our ABC triangle. It told us that the side length A was 2.4, side length B was 3.2, and angle A was 28. What we left off with last class was I said the first angle you're going to solve for is angle B, which is right here. And the reason why we need to solve for angle B is because we have side B, right? So we're given the side, which means we have to find the missing angle to that opposite side angle pair. So when we use our equation, our sine law equation, we're going to use sine. Since we're solving for an angle, we're going to use sine A over A is equal to sine B over B. And we plug in our values, we're going to get sine 28 over 2.4 is equal to sine B over 3.2. We then have to move the 3.2 to the other side by multiplying it over. And so we're going to get 3.2 sine 28 all divided by 2.4 is equal to sine B. And then since we want to isolate for B, we sine inverse this whole fraction. So this is what we learned yesterday, a reminder of how to solve using sine law. So doing this on your calculator here, you should get, and if you haven't done it, you should try it now. So sine inverse of 3.2 sine 28 divided by 2.4. And I get angle B is 38.8 degrees. Rounded to the first decimal place. Okay, so 38.8 degrees to the first decimal place. Any questions about this first part here?
Mister, so we always need to get rid of the sign, right?
If you're solving for the angle, yes, absolutely.
Okay.
For sure. So once you find the angle, if you want to write it into your drawing, you can. What's our next target? Now that we have angle B, what's easiest to solve for next?
Angle C.
Angle C.
Angle C, exactly, because we can do 180 minus our two angles, because the three angles inside a triangle add to 180. So when we subtract them from 180, we get angle C. So angle C is going to be 113.2 degrees. Now that you have angle C, you can now solve for side C, and you can solve it using the sine law again. And I'm going to use the angle side pair of A to solve this out. So if I, once again, just drawing it out here, this is 113.2. And the equation I'm going to use is C over sine C is equal to A over sine A. So because we're using, or we're trying to solve for a side now, I am now using the other version where the side length is on top. So plugging in our values, we get C over sine 113.2 is equal to A 2.4 over sine 28. This allows us to multiply the sine onto the other side, which gives us 2.4 sine 113.2, all divided by sine 28. and it gives us our final answer, which gives us 2.4 sine 113.2 divided by sine 28, and I get 4.7 centimeters. And that would be the full solution to your problem, where your answer, first answer, second answer, third answer. So this would be the full solution I should expect to see, right, when you solve a problem like this. Any questions about this sine law? Yes, I will post more practice problems and stuff like that. You can also use your textbook to solve the questions there, as I've written in the homework at the top of these lesson sheets. Okay, so let's try to make your day easier, right? And let's go through cosine law, and then we're done. That's today's lesson, just cosine law. Because to be honest with you, chapter unit 5 is actually on the shorter side, believe it or not. Unit 5 is on the shorter side. So we're going to be doing our cosine law today. We'll do test review tomorrow. And then we'll do test review take up tomorrow, and then your unit test will be after the long weekend on May 25th. Right? So you will have the weekend to study for your unit 5 test. So we're pretty much
Mister,
done. Yes.
sorry, I have a question. So for
Yes.
the last part, the C,
Mhm.
so you put the 3.2 at the right side, right?
The 113.2, yeah.
Yeah. Isn't it supposed to be like in the front of sin and then
It's because if you look here, sine 113.2 was what's underneath, right? So that's one huge group. So when we multiply it out, it's going to be over there.
okay. All right.
Right. So we're taking this whole group and we're multiplying it over, which means this is the first group and that's the second group.
But does it matter where it is or not?
So since this is just the number, this should go in front.
Oh,
The 113.2 is inside the sign, so you can't touch that one.
oh, okay. All right.
Good question. Any other questions before we move on to today's lesson? All right. So that puts us into learning cosine law today. If I'm kind of glitching, I don't think I'm glitching too much. If I'm kind of glitching, it might just be Wi-Fi issues. So hopefully that settles and you can hear me again soon. If I'm always glitching, then I might have to turn off the live stream, but we'll see. I don't think my internet is incapable of handling both, so it should be okay. Okay, so chapter 5.4, applying cosine law in acute triangles. So we've went through SOHCAHTOA, which is right angle triangles. We went through sine law, which is when we don't have a right angle triangle, what do? But there's going to be situations where you can't use sine law, right? So let's take an example of where you might have a situation where you can't use SOHCAHTOA or sine law. So if I draw this triangle here, I'll just draw like a random triangle here, something like this, right? So let's say I draw this triangle and I'll label it. Let's say I say this is 25 degrees, this side length is 3, and this side length is 5. And I ask, or like 7 or something. And I ask you, what is x? The issue here is, number one, I can't use sine law. I can't use sine law. Why can I not use sine law here?
You don't have a pair?
That's right. I don't have a side angle pair. Lorraine and Brooke said that, right? Side angle pair, we don't have anything, right? 7's angle pair would be here. We're missing that. 3's angle pair would be the opposite angle. We're missing that. And 25's angle, well, angle side pair, well, that's the side we're missing. So we come into this issue of sine law is not going to work all the time, depending on what we're given. So then, if sine law doesn't work, we go to our last option, which is cosine law. Okay, so cosine law will let us solve for what's missing here without having to worry too much about what it is, right? So basically, the order goes, can I use SOHCAHTOA? Yes or no? If not, move on. Can I use sine law? Yes or no? If not, then check cosine law. That's the order on which you should be checking. Okay? And the reason for that is because cosine law is a nightmare for most people. And that's fair. When I saw this, when I was in grade 11, I'm like, what the hell is this? I'm like, this formula is more complicated than I want to ever remember. A squared equals b squared plus c squared minus 2bc cosine A. And depending on what side or angle you have, the letters change. But let me break it down to you easier. The letter on the left, the side length on the very left equal sign, left of the equal sign, should be the angle inside cosine. So you'll notice side B on the left is angle B on the right in cosine. And side C on the left is angle C on the right in cosine. So that's the connection you want to make. And you'll notice that all of the other letters here are the two letters that weren't used. So if it's C, we use A and B. If it's B, we use A and C. And if it's A, we use B and C. So the cosine law can be written in multiple ways. But the main thing you want to remember is that the left and the very right should have matching letters. So lowercase c on the left means uppercase C on the right. Lowercase b on the left means uppercase B on the right, so on and so forth. Right? So we really want to remember that because this formula can get complicated, so on and so forth, especially when we start to reorganize this to solve for an angle. So what I usually do here is say, okay, this is nice and organized for solving missing side. What if it was a missing angle though? So let's talk about missing angles. This is what it looks like when you're solving a missing angle. So I'm going to write cosine A because you get rid of cosine by cos inversing the fraction just to save some writing and some complications here. It will become this. So that's the first one. Okay, I'm going to write all of them for you so you can have it all written out. Cosine B is equal to b squared minus a squared minus c squared all over negative 2ac. And cosine C is equal to c squared minus a squared minus b squared all over negative 2ab. This solving missing angle. I'm going to leave that there for you to copy down if you'd like. I will give these formulas to you on the test. Okay? They are a nightmare, right? It gets complicated. So to me, or at least, okay, so when I say I use cosine law last, most times when I start looking at a trig problem, I don't even think about cosine law unless I really have to. At least that's how I've done it in high school. That's how I kind of coped with it. I really didn't want to use cosine law because in comparison to SOHCAHTOA and sine law, cosine laws, to put it simply, it looks like a bitch compared to sine law and SOHCAHTOA, right? SOHCAHTOA seems so much easier. Sine law seems so much easier. The formulas are more straightforward. It's much easier to understand. But in comparison with cosine law, it looks more complicated and it's more complicated to kind of remember, right? Back in my day, I sound old when I say that, God. When I was in high school, which was 10, 11 years ago, right? we had to memorize this. We were not given these formulas on our test, right? So you can imagine how stressed and annoyed I was having to memorize a formula just so I don't mess up on a test, right? So luckily for you guys, you don't have to memorize formulas, right? Just worry about which form do I use when I'm solving a missing side or a missing angle, right? And it should be your last case scenario if sine law and SOHCAHTOA doesn't work, right? Because those two are the easier ones, in my opinion. You should get comfortable with those. And then cosine law is like the last case scenario. Sine law doesn't work. I have to do it. I have no choice. Or the question says use cosine law. Then you really have no choice. Okay. Are there any questions about the formulas themselves so far before we move on here? Going once, going twice. Okay. So there's two ways you can easily identify using the cosine law, which is when you have a side angle side, right? So you have side angle side like this, or you just have all three sides. In both of these situations, the only option you have is cosine law. No other choice. You cannot do anything else if this is the triangle information that you're given. Okay? So if you're able to quickly identify this, then you're good. Okay? And you can clearly see in both of these scenarios, there are no angle side pairs, right? There's no angle side pair on the first one, and obviously for the second one, there are no angle side pairs because there's no angles in the first place given to you. So as a result, you need to decide, oh, no angle side pair, cosine law, boom, and then get started. So let's go through our first example doing this. You'll see here, determine the length of C to the nearest centimeter. We're given side angle side. There is no angle side pair. This looks like a 90-degree triangle. It is not. Do not assume this is a 90-degree triangle unless I give you this. Okay? If I don't give you that, do not assume it's 90 degrees. Don't be like, oh, that looks pretty close to 90 degrees. That's probably what Mr. Choi meant. No. I will explicitly show you that it is 90 degrees. So do not assume that this is 90 degrees here. So since we are solving for length C, we are using this equation. C squared is equal to A squared plus B squared minus 2AB multiplied by cosine C. Okay? So we write down our formula and then we plug in what we're missing. So C squared, A is 5. Oh, sorry, 7. Sorry. B is 5. And we keep going. 7, 5, cosine 43. Now, when you do this math, some of you may be tempted to solve this whole thing all the way through. And if you're careful on your calculator, you absolutely can. You can solve this on your calculator. You can move on and just do C squared equals the number. However, knowing some of you and myself, I've done this mistake before, right? If you're like me, you may accidentally misinput because you misbracket somewhere, or maybe you misclick a button. And so I'm going to show you a quick way to break down solving this without having to do all of it at once. The main sections that I want you to do is the first section are the two squares. You should do that separately. And the second section is this multiplication here. So what's going to happen here for me, I'm going to do C squared equals 7 squared is 49. And then plus 5 squared is 25. Minus, and then multiply these three numbers here. 2 times 7 is 14. Times 5 gives me 70. So I get 70 cosine, whoopsies, 43. Just like that. Now, what we do here we can combine 49 and 25, and we're going to solve this section here. Okay? So 49 plus 25 is going to be 74. Then I'm going to do minus, and I solve this here. And you can do this on a calculator. 70 cos 43. Make sure you try it now. Keep getting their practice with your calculator so that you don't make a mistake on the test. 70 cosine 43 is going to give me 51.195 rounded. Okay. Now, if you wrote it to the first decimal place, it would be 51.2 here. So usually I write it, because I'm not rounding until the very end, I usually keep around 2 or 3 decimal places to make sure we're good. Then once we have that, we can now do the subtraction, and that brings us to c squared is equal to 74 minus this, and I get here. So if you're good with the calculator, you can jump from here all the way to here, and I'd be okay with that, right? If you correctly input it on a calculator, right? So let me show you how you can correctly input this on a calculator real quick, just to show you. With no mistakes, if you were to input this on a calculator, this is what it should look like. As I launch my program here. There we go. Okay. So if we type it all into our calculator correctly, I should get 7 squared plus 5 squared minus 2 times 7 times 5 times cosine of 43. And that gets me my answer right away. Okay. So I can do it all at once, or you can type it in your, I can do it all at once like this on a calculator, or do it step by step like I just did, right? If you do it step by step, section by section, the math becomes a little bit easier to understand, right? We have this adding to here. We have this adding to here, or multiplying to here. We have this multiplying to here. And then we have this section multiplying here. We have this section multiplying here, right? It breaks it down into simple math so that you don't make a mistake, right? So it is your choice how you want to do this on a calculator. If you want to do it really quick and you type it in correctly on a calculator, you may do so. You're free to do so. I have no complaints. From here, once we get to c squared, we're going to square root both sides, like so. And we're going to get c is equal to the square root of 22.805. That gives us 4.775, which is rounded to 4.8 centimeters. And that would be our final answer. Any questions? Oh, that's true. Nearest centimeter. That is correct. Yeah. 4.8 centimeters, which is rounded to the nearest centimeter, 5 centimeters. Thank you, Brooke, for catching that, because it's to the nearest centimeter. So 5 centimeters would be your answer for this one. Any questions? Okay, so let's continue on from there. Now let's go through our second example here, which is, what if I give you 3 sides? So we have these 3 sides here. What do we do if we get all 3 sides here, right? So 3.2 kilometers, 6.2 kilometers, 5.9 kilometers, and it says to find the angle R. It says to find R here. Okay. If you don't like PQR, fine, change it to ABC. I don't care. If you don't like it and you're like, Mr. Choi, I hate using any other letter, fine, change it. I honestly don't care, right? So feel free to change it accordingly if you need to, right? So that it's nice, and if that helps you with your solving. But I want you to get comfortable to just use any letter, because a lot of you get really caught up in using just A, B, and C because that's what the formula gives you. But I want you to get to a point of understanding where it doesn't matter what the letters are, right? A, B, and C are just placeholders for their positions, right? So for us, this would be lowercase r, this would be lowercase p, and this would be lowercase q. And our formula that I would use, since we are solving for an angle, I would use cosine r is equal to r squared minus q squared minus p squared, all divided by 2pq, or qp, negative 2qp. Okay. If you were to use A, B, and C, notice how if you just replace the letters accordingly, you should be able to get this formula here from above. When you plug in the numbers, you're going to get cosine r is equal to 3.2 squared minus 6.2 squared minus 5.9 squared, all divided by negative 2 times 6.2 times 5.9. If we do this one section by section, I say do the numerator all at once and then do the denominator all at once. So I'd keep the fraction line here. And so on my calculator here, I would do 3.2 squared minus 6.2 squared minus 5.9 squared. And that gives me my answer of negative 63.01 up top. And then for the bottom one, I just multiply negative 2 times 6.2 times 5.9. And I get negative 73.16. Just like that. Okay. What this allows us to do now is just cos inverse this, right? I can cos inverse the fraction. So on my Android calculator, if I do that, cos inverse of negative 63.01 divided by negative 73.16 gives me R is equal to 30.5. And rounded to the nearest degree would be 31 degrees. Okay. So make sure you're able to do this on a calculator correctly. Really important that you are able to do so. Okay. And it's just the understanding of deciding and identifying, hey, this is cosine law, I need to use it. Now, a situation I want you to understand here. Let's say I just said solve this triangle. Do I have to solve for R? No. I could solve for P. I could solve for Q. I could solve for any of these angles really using cosine law, right? If I really wanted to. So when you're given all three sides, you get to pick which angle you want to solve for. Okay? So then let me ask a question here. If I find R and I found it to be 31 degrees, what do I solve for next and how?
Can we solve the next angle, P?
Yep, you can solve for angle P.
And then
And how would you solve for it?
use
Sine.
Sine law, exactly. Now that we have the R, we have an angle side pair, we're allowed to use sine law. And Lorraine said you can solve for P. You can actually, yeah, that is correct, because you can choose whether you solve for P or Q, because you have lowercase p and lowercase q. Then what Lorraine was mentioning at the end was to subtract the 2 from 180 to find the last angle.
Can we use Sokotowa too for this?
You
No.
cannot use SOHCAHTOA here,
Okay.
because SOHCAHTOA only works for 90-degree angles in a triangle, right angle triangles only. Okay. Sine law and cosine law works for any triangle. SOHCAHTOA only works for right angles. So you can use sine law for right angle triangles too if you wanted to. Okay. So same thing I'm going to do from yesterday. Example 3 will be your work, the minimum work you actually have to do before tomorrow's class, tomorrow's morning class. Tomorrow's class is going to be a review time and then test review take up. Like, we're going to take up the review as well. So make sure you try some of the homework. Make sure you practicing, because your test is the day after Victoria Day. Long weekend. Woo! Okay. So example 3, word problem. It says Ken's cell phone detects 2 transmission antennas, one 7 kilometers away and the other 13 kilometers away. And from its position, the 2 antennas appear to be separated by an angle of 80 degrees. How far apart to the nearest kilometer are the 2 antennas? What I would like you to do for the next 2 minutes on this question is to draw the diagram. Can you please draw the diagram for me of what the triangle looks like, and then indicate what we're trying to solve for? Okay? 2 minutes. Another minute. Okay. So the diagram you should have here, hopefully you have something like this, or at least a triangle, something like this. Your numbers here, it doesn't matter whether you put 7 on the side or 13, but 7 and 13 should be here. So if you wrote 13 and 7, that's right too. So don't worry. So 7, 13, and this angle here says it's 80. From here, you can label your triangle A, B, and C, which means I would be solving for A here. If your triangle looks something like mine, good job. You're good to go and you're ready to solve this problem, which means you're solving for lowercase a here, right? This is going to be your work, of course, for tomorrow before we take it up. And of course, please study for your Unit 5 test or get started on it. I have uploaded a practice Unit 5 practice test for you to do. There is an answer key on it. You will have time to work on it in class tomorrow, and we are going to be taking up some of those questions tomorrow as well. Otherwise, look, we're done Unit 5. That was it. That was Unit 5. Pretty fast. So if you have any other questions, you can stay behind for a little bit. Otherwise, if you're done copying this down, you can go solve it. Have yourselves a wonderful rest of the day, and I'll see you tomorrow morning, 8:45 if you want to chill, 9 o'clock for the class.